Hello everyone, MK's here. This session I will be discussing problems based on Coulomb's law. Those problems are only of few types, but some problems you need to know the knowledge you have gained in class 11 physics. Like simple harmonic motion concept is required in some problems of Coulomb's law. Like stable and unstable equilibrium concept is also required when the body displaces from equilibrium position. Whether it will perform stable equilibrium or not, that you have to remember. This will perform stable, the substance will be in, the object will be in stable equilibrium if it is perturbed, disturbed from its equilibrium position slightly by some distance, then restoring force directed towards the equilibrium position, then only it will be stable equilibrium, otherwise not. All these concepts require basic concept of string mass problem. When mass is suspended from the end of a string, what is the time period of pendulum, all these things I hope you remember. So without wasting time, let us start problem solving in Coulomb's law. All the best. If you go through sums given in your textbook or Concept of Physics by H.C. Verma or Cengage or any standard problem book, then you will see that the problems based on Coulomb's law is mainly divided into these four categories. Equilibrium of charge. On equilibrium of charge, that equilibrium of charge means equilibrium among group of charges, and equilibrium when stable, unstable, and neutral equilibrium considered. There are problems based on permittivity, application of vector form is there, and Coulomb's law in SHM there. Any problem given in the book comes under these four categories when the questions are on Coulomb's law. Equilibrium of charge itself can solve many problems if you have clear idea about stable unstable equilibrium or equilibrium in the group of charges, but it is sometimes related to vector form. Why I have taken vector form separate? Because some problems are there which can be done with the help of vector form only. Vector form of Coulomb's law has vast application, can be used any problem when you are solving from electrostatics or Coulomb's law. So let's see what kind of sums we can solve today's class. Let us start with this problem where I have taken solving problems in SHM by using Coulomb's law. Simple pendulum of length 1 meter carries a charge of 2 microcoulomb at its lower end. So there is a simple pendulum suspended from here. This pendulum has some charge which is given as, we are this data you also can put. Just let me explain how to solve the sum. Charge on this be Q. That Q is equal to 2 into 10 to the power minus 6 coulomb. Length of the pendulum is 1 meter. L. Length of pendulum is equal to 1 meter. And there is another charge placed below it at a distance 0.5 meter. Okay, this charge is placed at a distance 0.5 meter. This also I am keeping in the form of some distance which is equal to r. R is equal to 0.5 meter. Question is, calculate the time period of oscillation of the charged pendulum. Mass of this pendulum is given. Mass you assume that equal to 0.3 grams. This pendulum bob has mass 0.3 gram. These values will put to get the exact data. First, to understand how to solve this kind of problem. This charge is given to be, say, q dashed, similar identical charge q. This is also q dashed, which is equal to q. Time period of simple pendulum, can be determined by using this formula, t equal to 2 pi root over L by G. But here, G will be affected because of electrostatic force of repulsion. This charge Q will exert force of repulsion on the charge lying above it. That is, charge of the pendulum is affected by it. That force will be in upward direction. That electrostatic force is given by Fe equal to Q square by R square. This multiplied by K. Okay. This electrostatic force is there and weight of this pendulum bob is also there. We are considering equilibrium of this bob. Okay. On it, what are the forces acting? Whatever it swings or that whatever kind of displacement you have given, that you have to keep in your mind that that displacement should be less than 4 degrees and 4 degree. I mean that angular displacement, then only it can perform simple harmonic motion. You have given a very small displacement this, and this is executing simple harmonic motion. Okay. And time period normal condition given by this, but here electrostatic force of attraction acting upward, weight mg downward. So the effective gravity force is reduced here, effective force acting on the pendulum. That acceleration you are taking g effective, that mg effective is going to be equal to mg, that weight minus Fe, the electrostatic force. It acts upward. So G effective will be equal to G minus Fe by M. Alright. So this time period formula now going to be changed because effective value of G is G effective equal to G minus Fe by M. Fe, I have given you this expression here that you know very well, kq square by r square. So time period t dash going to be equal to t 2 pi root over L by G effective. Substitute the values given over there. L by G effective is G minus Fe by M. Fe you got there. K into Q square by M into R square. Value of K you know very well, 9 into 10 to the power 9 SI unit. Okay, already told. The mass is 0.3 gram we have taken. R, the distance is given to be 0.5 meter. This R is 0.5 meter. Just substitute the value. You'll observe that time period of oscillation is increased. It takes more time. What will happen if we keep the charge just above it? Not here. Charge we are keeping here. In that case, mg acting downward. If the mass is kept above the bob of the pendulum, then the situation will be like this. We are repeating the same problem here, and it is like this. This bob, it has weight mg, and this equal mass we have kept just above it, vertically above it. It all identical mass given, charge is q. Okay, then in this case the G effective value will be calculated like this: m into G effective equal to mg plus Fe. So G effective is going to be G plus Fe by M. Okay, Fe value will remain the same because distance is R only, everything remains the same, only this time it is added. So T dash, the time period will be 2 pi root over L by G plus Fe by m. Fe value is there, m is there, just same calculation. Instead of minus, there will be plus sign. This you can complete. Hope you have understood what you have to do when this kind of problem arises. The effective value of G to be taken into consideration. Okay. Now let us go through the next problem. It's a very important sum. This question is such an important sum, can be asked the concept in your board exam. In any competitive exam, the kind of question can be asked. So you should try to understand the problem properly. Okay? What is the problem here? That two particles A and B, each carrying a charge Q, were held fixed with separation D between them. A particle C having mass m, charge Q, is kept at the middle point of the line AB. If it is displaced through a distance x perpendicular to AB, what would be the electric force experienced by it? And then assume Ax very smaller than D, so that force is proportional to x. Under what condition this will execute SHM? If it is released after such a small displacement, and find the time period of oscillation if these conditions are satisfied. It's a very good problem, and this time let me explain the first part of the problem. That A and B, these are two charges Q each. They are kept separated by distance D between them. Particle C, this particle is A, this one B. Particle C is kept here, having charge Q. It is displaced through a distance x. This particle at C, you have taken some other point, say C dashed, by distance x. Okay? This one has charge Q. This one has charge Q. It is displaced by distance x. And they ask you to assume x is very smaller than D. What D stands for here? A to C distance given to be D by 2, and C to B, that distance also D by 2. Okay? Now, we are initially assuming that this charge is positive. Then in what direction forces are going to act? Forces are going to act this manner. Charge at C will experience a repelling force this manner. Isn't it? This force I am writing F C A. Okay? Charge C carrying charge Q experience. This is just for position C dash to have taken. And another one from B to C. What kind of force is acting? That is also repulsive force. And that force is going to be F C to B. You all understand? So these two forces have some resultant force. We have to find the resultant one. This resultant force will take the particle away from this combination of two charges. Let us calculate this. If this angle is theta, this one theta, then this angle going to be 90 minus theta. This is also 90 minus theta. Sum of these two going to be 180 minus 2 theta. The resultant force is here, that Fr equal to under root, this is going to be under root Fc square plus FCB square plus 2FCA FCB, and then the angle between two charges 180 minus 2 theta, that we need to substitute cos 180 minus 2 theta. Isn't it? FCA FCB value also let us write. What is FCA? See, similarity is there, direction is different, Q and Q interacting. So FCA, the magnitude of that force, and magnitude of this force FCB will be equal to QQ by R square. This R is how much? In this diagram, R square is x square plus d by 2 whole square. Alright? So KQQ by R square means x square plus d square by 4. So FR going to be what? FR will be under root. You just substitute these values FCA, FCB equal. So you write twice FCA square cos 180 minus 2 theta is what? This is twice FCA square cos 180 minus 2 theta is minus cos 2 theta. Alright? So you take 2 FCA square common. 1 minus cos 2 theta is what? That you know very well. Hello, ma'am. Hello. হ্যাঁ ম্যাম, গুড ইভিনিং। কাল কখন আসবে ম্যাম? 9টা থেকে 9:30। আচ্ছা ম্যাম, আমার মনে হয় পরশুদিন একেবারে শুরু করাই ভালো নয় কি? কেননা আমি ওদের খাতা দেব সেই দিনেও, মানে ওদের ছাড়বো না যে শুধু ওই মক পেপার দিয়ে হয়ে গেল তা নয়, 5টা বা 10টা কারেক্ট করিয়ে নেব। হুম। আচ্ছা ম্যাম, সিবিএসই কি কোনো দিচ্ছে তো, মানে টাকা পয়সা দিচ্ছে জেরক্সের জন্য তো? কেননা গতবার কিছু দেয়নি তো ওরা, পুরো নিজের দিয়ে করিয়েছিলাম, ওরা একটা পয়সা করেনি। তাহলে কি জেরক্সের কি করা যাবে? হ্যাঁ হ্যাঁ, আপনি আমাকে পাঠিয়েছেন। আচ্ছা, আর খাতা? তাহলে আমার মনে হয়, হ্যাঁ, আমি তাহলে ওদেরকে গ্রুপে লিখছি যে 10টার সময় কতজন তোমরা প্রেজেন্ট হতে পারবে, নাকি না 10টায় আসতে বলে দেবো ওদের? আচ্ছা, ঠিক আছে। আর ম্যাম, শুনুন না, ওই ওর নাম কি, জেরক্স বাবদ কন্টিনজেন্সির টাকা কি কিছু দেবেন আপনি? কিন্তু আগের বার তো দেয়নি, 10,000 ম্যাক্সিমাম দিয়ে পাঠিয়ে দিয়েছে, বলেই দিয়েছে এই শুধু 10,000 টাকা পাবে। একটা পয়সা দেয়নি গত বছর, কি করা যাবে আপনি একটু জেনে নিন না ম্যাম। কন্টিনিউয়াসি ব্যাপার মনে হয় আপনার কাছে আসবে, এরকম কিছু আছে যেগুলো অন্য সেন্টারে করছে। আপনি খোঁজ নিয়ে দেখুন ম্যাম, সে জেরক্স ওখানের লোকই করুক, কোনো অসুবিধা নেই, কিছু লাগে সে দিতেও হবে, কিন্তু সিবিএসই পুরো আমার 2400 টাকা খরচ হয়েছিল, একটা পয়সা দেয়নি গত বছর, একটা পয়সা দেয়নি। আপনার সঙ্গে যখন কারেক্ট করে এলাম ওখান থেকে, একটু দেখুন ম্যাম প্লিজ। হ্যাঁ, আর আমি গ্রুপে লিখছি যে কপিজ আর ইয়েট টু রিসিভ। হ্যাঁ, ওকে, ঠিক আছে ম্যাম, আমি বলে দিচ্ছি। হ্যাঁ, আর এলেই ম্যাম একটু আমাকে জানিয়ে দেবেন, হ্যাঁ, তাহলে ওদেরকে জোর দেবো তখন যে তোমরা চলে এসো। So this is 2 FCA square 1 minus cos 2 theta, and 1 minus cos 2 theta formula you know very well, that is 2 sin square theta. So this thing will be 2 into FCA square into 2 sin square theta, which is nothing but 2 into FCA into sin theta. Okay, so repulsive force acting on charge at C calculated here, which is given by twice FCA sin theta. If we substitute the value of sin theta, you all can see in this diagram what is the value of sin theta. Just check the diagram. The value of sin theta in this diagram going to be equal to, this is perpendicular hypotenuse, that is x by r. R is nothing but under root x square plus d square by 4. So the repulsive force you got by calculation, which is given by 2 into FCA we have written KQQ by d square by 4, and sin theta we have seen x by r square is x square plus d square by 4, so r is equal to under root x square plus d square by 4. So this thing is under root x square plus d square by 4. This is the answer to the first part. So the value we got, Fr is given to be, Fr, finally we got this thing, 2kqqx by x square plus d square by 4 to the power 3 by 2. Alright. Now, it was displaced by distance x perpendicular to AB. What would be electric force experienced by it? This is the answer. First part answer is this here. Okay. Now for the second part, assuming x very smaller than d, so that this force is proportional to x. This we do by some approximation where x is very smaller than d. X very smaller than d implies x square plus d square by 4 approximately equal to x square. Isn't it? Because x is very smaller than d. So, no. This will be approximately equal to d square by 4. Because x square you can neglect in compared to d square by 4. There is another way to show this by using binomial expansion. I am just not taking the help of binomial expansion for this particular sum. As x is very small, we ignore x square in compared to d square. So if you write x square approximately x square plus d square by 4 approximately equal to d square by 4, then Fr is changed to twice kqqx divided by, we ignore this x square part, so it will be d square by 4 to the power 3 by 2. Alright. So this is nothing but twice kqqx by, this is d by 2, d square by 4 means d by 2 whole square to the power 3 by 2. This is nothing but dq by 8. So substitute there, it is dq by 8 now. So this is nothing but 16 kqqx by dq. Okay. But their requirement is just this thing. Under what condition will the particle C execute simple harmonic motion? If it is released after such a small displacement, the next part is find the period of the oscillation if these conditions are satisfied. Okay, very interesting question. First and second part both are done. Now this particle, the charged particle at C, can execute SHM if there is a restoring force. But the force you have calculated, this is repelling force. Under what condition this is going to be the attracting force? I mean, restoring force will be there. That charge Q has to be small. If Q is, that charge Q is negative. If Q is negative, then Fr going to be equal to, just put negative sign over there. For Q be negative, if Q less than 0, then Fr going to be minus 16 kqqx by dq. Alright. Since Fr, you know this condition of SHM, as Fr proportional to x, that restoring force, here now it has become attracting force. You just write attracting force here. Since Fa proportional to x, therefore motion is SHM. Okay? And how to get the time period? That Fa, the restoring force here, you compare with minus m omega square x. You have done it in class 11. The restoring force compared to m omega square x will give you omega from their time period. So you just compare m omega square x will be 16 kqq by dq into x. This thing getting cancelled. So omega value is under root 16 kqq by m dq. But omega is what? Omega is 2 pi by time period. So just substitute the value over there. Therefore, 2 pi by time period is under root 16 kqq by m dq. Alright. From there, we can get the value of time period. So t will be equal to what? 2 pi under root m dq by 16 kqq. Alright? You all understand? So this way time period can be determined. You just put the value of k over there, which is 9 into 10 to the power 9. For a numerical problem, you can get the value of t from here, time period. Now a question for you. You just try to calculate the time period if the charge was lying on the axial position, means A and B are there, and then A there, B also there, and charge C is just given displacement along the length. Then what will be the time period for the same problem? Understand, this is a very important problem. The third charge Q given a very small displacement along this direction. Then you find the time period and get the ratio. Believe me, this is board question, this is entrance exam question, this came in JEE main, many JEE exams. So if you compare the time period, the problem I have solved here, and when it is given displacement along the length by distance, very small distance x, condition remain the same, but here displacement given along the length, then what will be the time period and what is the ratio of the time period? This you have to, time period in this case and time period in this case, their ratio. This you try at home. If you cannot solve it, please write in the comment box or communicate with me to ask you a question. Let us go for next problem. This is another question on equilibrium. Alright. Here it is given two small balls with equal positive charge Q Coulomb suspended by two insulating strings of length L meter from a hook fixed to a stand. Whole setup is taken in a satellite into space where there is no gravity. Find the angle between the strings and the tension in each case. Very interesting problem. Two small balls suspended by two insulating strings from a hook fixed to the stand. Okay, attached here. The whole setup is taken in a satellite into space where there is no gravity. This is noticeable. There is no gravity. Then the question is, find the angle between the strings and tension in each string. See, this charge is Q. This one Q. What kind of force exists? Repelling force only, isn't it? So if you take them in satellite, then no gravity acting. Why? In on the surface of the earth, they will maintain equilibrium this way, mg will act this way, there will be tension, and if this angle with the horizontal be theta, then tension component T cos theta will act this manner and T sin theta will act this manner. Isn't it? Then repelling force Fr will be balanced by T cos theta. Then equilibrium, for equilibrium, T cos theta will be Fr. I am just discussing general case what happens actually, and T sin theta equal to mg. This will help you to calculate tension produced in the string, the angle theta, even that angle 90 minus theta with the vertical also you can find. But here problem is different. This whole apparatus is taken in a satellite. No gravity is there. Then what will happen? These two masses, due to their force of repulsion, will be separated. From here, they are going to be separated like this. Okay, they become horizontal. So the angle between two masses going to be equal to 180 degree. Isn't it? So here repelling force still acting, Fr, that will act. That is not dependent on force of gravity, that I told you both are fundamental forces, gravity and electrostatic. So repelling force on this mass will act this way, on this mass will act this way. Okay, and tension will be acting this manner. This is the direction of tension. This tension will balance the repelling force. Question they asked, angle. The first part answered that angle going to be equal to 180 degree. This theta 180 degree, and tension will balance the repelling force Fr. Fr is what? K into, they have charges Q each. Kq square by L meter is this distance, this one also L. Total length is 2L. So tension we can get by putting the value of K, Q and 2L. That 4 into 10 to the power 9, I remind you once more, by 4L square. This is going to be the value of tension in this case. Okay? You don't be tense, please. Because these kind of questions are very common. You have to learn it to master the sums given in electrostatics. Let us see the next question. Two identical pith balls, each carrying charge Q suspended from common point by two equal strings. Just like the previous sum, I have shown you in the diagram before. The same diagram we can take here also. Okay, so they are separated from each other by what? By the repelling force. Repelling force will act this manner. Here also repelling force act this manner. This is the vertical line we have taken. Okay, tension of the cord will act this manner. This is true for both. What we are doing for this one, the mass here, same thing is true for this. What is acting here? That weight mg, vertically downward, Fr this way. This separation, strings length only given, this is L, this is L, this separation not given. This separation not given, charges at A and B, what is the separation between them? But one thing given, the two strings makes 2 theta in equilibrium. 2 theta in equilibrium. So this part going to be theta, this part is also going to be theta. So this tension you resolve into components. If you have taken this angle theta, this is 90 minus theta. Isn't it? That's why I am taking different diagram, not like previous one. Tension is component this way, T cos 90 minus theta, and this way it will be T sine 90 minus theta, that is T cos theta. You all understand? Similar is the case for this bob also, that mg acting downward. Fr this way, and this one also theta. This way it will be t cos theta. This way it will be t sin theta. So this is common type of equilibrium problem which you have seen class 11 problems in some problems like pendulum. Here the difference is there is a repulsive force Fr between them. This distance between A and B we are taking 2r. This part r, this part also r. Then r is well defined term here, r by L. You can see in the diagram this is going to be sine theta. Isn't it? Question is find the mass of each ball if the angle between the string is 2 theta in equilibrium. So write equilibrium. For equilibrium, you write t cos theta mg and t sin theta will be balancing the repelling force. That is nothing but kq square by 2r whole square, because distance we have taken 2r. AB equal to r plus r, that is 2r. Okay. So this is number 1 and this is number 2. We can find mass just by dividing. Okay. No separate condition given here. They haven't told that distance small, large, that we don't know. So what we'll do here, that we'll divide 2 by 1. Dividing 2 by 1, tan theta going to be kq square by m into 4r square. Alright. So m going to be what? kq square by, this is, this not m, it will be mg. No, this divided by this, mg is there. So 4g, m will not be there, m we have taken on the left hand side, 4g r square. Alright. R value you can substitute. What is the value of r? R is equal to L sin theta. Isn't it? So you can substitute the value of r over there. That is L sin. Theta is a given quantity. You can easily substitute. So kq square by 4g into r is L sin theta. You put there L sin theta whole square. I hope you have understood. If any numerical question given over there, you have to put this value of q, L and theta. Now there is another equilibrium question given here. A charge q is placed at the center of line joining two equal charges, so that system of 3 charges will be in equilibrium if small q equal to this. Okay. This is another very interesting, very good problem. Why? Because here, if you consider equilibrium of what? Let me draw the diagram. This is Q. This is Q. Small charge Q is placed. Center of line joining two charges. System of charges will be equilibrium if this is equal to this. First thing, equilibrium is impossible if these two charges and this charge all are negative. So first thing you have to make clear here, all charges can't be similar. Okay, this is one very important observation we have made here. Because only repelling force act, then it is not possible to balance. On Q, repelling force act, small q, big Q, whatever, only repelling forces act, then equilibrium not possible. But if you make one arrangement, if you make this charge minus Q, then everything done. This has to be negative. This has to be negative, then equilibrium of every charge is ensured. This Q is repelled by this one. and attracted by this one. Balanced. This Q is attracted by minus Q and repelled by this. So repelling there, attractive also there. Balanced. Minus Q, it is attracted by this charge kept here and the charge kept here. Balanced. Minus Q is in equilibrium. Okay. So based on this, we have to find. Now it is given that the distance, it is midway at the point M. If the total distance AB we have taken 2A, then this part is A and this part is also A. So how to find the value small q? Small q not given. Small q you have to find, or you have to get the condition here for equilibrium. What kind of equilibrium here? No stable, unstable equilibrium. This equilibrium is just force acting on each charge equal and opposite. So here minus q will experience attractive force both the way. It is balanced. If you consider this thing, equilibrium of this particle, then you won't get the value of q because q get cancelled. Isn't it? If you consider equilibrium of considering equilibrium here, q by a square will give you just q by a square. Will you get the value of q? No. To get the value of q, we consider equilibrium of q at B. You just consider equilibrium of q at B. F BM is going to be equal to FBA. FBM means what? Force experienced by charge at B due to M. What force is there? KQQ by a square. This force experienced repelling force going this manner. This is the repelling force. So it is K Q square by 2A whole square. Understood? That Q get cancelled. So we get Q equal to A square get cancelled. It is becoming Q by 4. The answer is minus Q by 4 because this charge has to be negative. Okay? So this equilibrium is possible when Q is Q by 4. Now another question here. Just go through the sum here. Two fixed point charges plus 4E and E are separated by distance E. Where should the third charge be placed for it to be in equilibrium? Third charge. So this has link with the previous sum. Two charges 4E and E are given here. Where should the third charge be placed for equilibrium? Third charge sign is not given. If it is positive charge, you keep it here, then equilibrium, that everyone is experiencing repelling force only, not possible. So here also the charge has to be placed somewhere in between these two. Okay? This is A, this is B, you are keeping it C. And the distance of this charge, third charge is not given. Let us assume Q. This distance be X. Then what about this distance? It will be A minus X. Understood clearly? Everyone, that C will be negative charge. C must be charge at C. Charge at C must be negative. Okay? Where should the third point charge be placed for it to be in equilibrium? We are keeping it at a point in between because negative charge can keep the system in equilibrium. We have seen in the previous example. This X we have to find. This time we consider equilibrium of this because we have to cancel E from both sides. So what is happening there? This is negative charge. It will experience FCB this manner. It will experience FCA this manner. So put FCA equal to FCB here. FCA is what? 4E into Q by x square E into Q by A minus x whole square. Alright? So now terms getting cancelled from two sides. E into Q get cancelled. K also, K, E, Q get cancelled. So this implies A minus x whole square is x square by 4. Therefore, A minus x is plus minus x by 2. Taking plus sign. What do you observe if you take plus sign? A will be 3x by 2. Otherwise, it is going to be negative. Negative means outside, we will not consider. So, x going to be equal to 2a by 3. Now, question arises, minus is possible. If you take the negative charge here, then also equilibrium possible. Why? Because negative charge, no, there's negative charge only. You cannot balance. This will attract, this also will be attracted. So, equilibrium not possible. So, we will not consider negative sign over there. We will be taking, just a minute. If you take negative sign over there, then a minus x is minus x by 2. A is equal to, no, this is not possible. Equilibrium will not be there if it lies at midpoint. Midpoint not possible. X will be equal to 2a by 3. Because then unbalanced forces will come here. Not equilibrium. No equilibrium will be there. So x will be 2a by 3. Now the next question. Three charges are placed at the vertices of an equilateral triangle of length L. How can the system of charges be in equilibrium? Three charges there. Q, Q, Q. They are placed at vertices of equilateral triangle of length L. Okay? There will be equilateral triangle. This diagram is not like equilateral, so take the charge Q here. The question is how the equilibrium condition will be maintained over there. There are equal magnitude, equilateral triangle of side length L, they are placed. System will be equilibrium where equilibrium of each charge is ensured. See, in this problem, Q's are same. But if they are different, then also we follow the same procedure. Okay? So, equilibrium is possible if one of the charge, second one of these, third one of these, all these are in equilibrium. But if you consider forces acting on the charges here, on this charge, what force is acting? Force is acting this manner. This force is FBA. If you consider equilibrium of charge at B. This force is also acting. It is FBC. So, if we just consider equilibrium of this, then only with these three charge equilibrium not possible. It will fly away. To keep it stationary, we have to find a place where equilibrium is possible. You can keep the whole system in equilibrium. So the point I am finding by symmetry, that is going to be the centroid of the triangle. If I keep a charge negative, that Q dash charge I am taking, say, then Q dash must be negative. Q dash sign is less than 0, then equilibrium is possible. Because this situation will arise for this charge, it will be experiencing repelling force, Q dash will attract. This one also will experience repelling force, Q dash will attract. So to keep the system in equilibrium, this Q dash must be less than 0. Okay. Now this angle you know pi by 3, 60 degree. F BC and FBA, their magnitude you know K into Q square by ABC is how much? KQ square by A square. So FR, this resultant, let us find first. FR is going to be what? You assume that this thing equal to F. So F square 2 FF cos 60 degree. So this is going to be 2F square 1 plus cos 60. Cos 60 is half. 3 by 2. 2 get cancelled. So F root 3. So this charge experiencing repelling force due to these two. Third charge will be attracting in a direction opposite to it. Okay. Third charge will attract it towards the centroid. Similar is the case for all the charges. This centroid we are taking G. So if Q dash negative, this is repulsive force. Attractive force acting on Q at B is going to be K Q dashed by this distance. Centroid to the vertex GA or GB or GC is 2/3 of height of the triangle. Height of the equilateral triangle is what? Root 3 by 2A. So this is A by root 3. So it is Q dashed by F attractive Q dashed by A by root 3 whole square. So this is 3Q dashed by A square. Alright. Now you can make this F and this F same. This F going to be what? That F is known. That F is how much? That is KQ square by A square. So it is. Now make them equal. So comparing these two, we get the value of Q dashed. By putting, you just put FA equal to FR. Just put it. Put FA equal to FR. Alright. These two get cancelled. These two also. KK also. Therefore, Q dash going to be Q root 3 by 3 and it is negative. So the third charge Q dash, this is one of the arrangement. You can think at home what other arrangement can be there. So equilibrium is possible if this Q dash equal to Q by root 3 or minus this charge is negative. Charge is Q dash is negative. We have taken the positive part of it. The required charge will be minus Q by root 3. Hope all of you have understood. Now the next question is 4 equal point charges each of magnitude plus Q are to be placed in equilibrium at the corners of a square. What should be magnitude and sign of the point charge that should be placed at the center of the square to do this job? Concept is like previous sum here, that center of the square you have to keep another charge like that equilateral triangle we have considered. Okay, this is Q, this one Q, and this is also Q. So what is happening there? Like equilateral triangle, each charge experiencing some force. This time we consider the force experienced by this charge. In what direction? This way. You name this one at A, B, C, D. Q charge is there also. So this will experience FBC, the repelling force. This will experience the repelling force FBA. Same charge will experience repelling force due to charge at D also. This is FBD. Okay? And then system will never be equilibrium if all these repelling forces are acting. You need a point where another charge is to be kept to keep the whole system in equilibrium. Again, by symmetry, the point we claim that here, which is the point of intersection of the diagonals. This point be O. You keep a charge Q dash here to keep the system in equilibrium. A very interesting fact you have to observe that when you calculate FBA, this force, and FBC, they are equal. They are equal to what? FBA and FBC, if you calculate, FBA and FBC going to be equal to KQ square by E square. And FBD is what? KQ square by this distance. That length of diagonal is root 2a. Very simple geometry concept. And these two forces are equal. So it will act along FBD only. So resultant force going to be what? Understand what I told? FBA and FBC equal. This angle 90 degree. It will act along the bisector, that is along BD. FBD is acting this way. It will act along that manner. Okay? It is resultant of FBA and FBC. That we take FR. FR is resultant of what? FBA and FBC. This is under root. They are at right angle and they are equal. So it is 2FBA square, which is nothing but FBA root 2. That is KQ square by A square root 2. Alright. So net force going to be what? Will be FBD, that is KQ square by 2A square plus KQ square by A square root 2. What this charge doing here? This Q dash? I told you Q dash must be negative. Now Q dash will attract this charge Q. Show that this resultant force and this one, this attractive force, are balanced. So let us calculate that attractive force acting on the charge Q dash, the negative charge at O. FA equal to what? Force between these two? KQ dash Q. What is the distance here? This distance R equal to BD by 2. This is A root 2 by 2. A by root 2. So F attractive is A by root 2 whole square. Now we can compare these two things, that net repulsive force and net attractive force is here. You just compare these two. Net repulsive force F are dashed and this, put this repulsive force KQ square by A square as common, 1 by 2 plus root 2 equal to KQ dash Q by A square into 2. So A square get cancelled, KK get cancelled, QQ get cancelled. The value of Q is coming here. Q into root 2 plus half by 2A. This is going to be the answer. Alright. So that charge is negative. This you must keep it in your mind. Okay. Now let us consider today's session will be completed with this sum. 4 identical Point charges are placed at corners of square. Fifth charge placed at center. So the net force experienced by it 0. Like previous sum, no? You all can see that. Why are you doing it then? This is like previous sum only. They are placed at the vertices of square. And you keep a third charge over, fifth charge over there. These charges are, say, Q each. Equilibrium is not possible. It is possible if you keep the fifth charge, which is negative here. If you keep a negative charge, this is not Q dash, this is Q. Like previous sum, we have calculated that charge also. That charge, if you keep here, that minus Q dash, whose magnitude is given here, then the system will be equilibrium. But question is different here. Fifth charge, what's the magnitude? That answer is there in the previous sum. Is this stable equilibrium? Very good question. Is it in stable equilibrium? Stable equilibrium means what? You need some concept of stable equilibrium. If you perturb the system, if you take this charge in any direction, if you displace it in any direction slightly, then the restoring force will be directed towards O. If it is directed towards O, then it will be in stable equilibrium. In general, this is not possible. I'll tell you why. Then it will never be in stable equilibrium. If we take this charge minus Q dash from here to here, minus Q dash we have displaced slightly, we have taken it O dash. Then this one attracting. That's true that you know. This one also attracting. This one attracting. This one attracting. Okay? There is no symmetry because this distance gap is there. O dash has some distance. So this charge will attract this way, resultant force will go this way. Resultant of these two forces will go this way, F1 say. And resultant of these two forces will go this way. Just opposite to that. But they're not equal. So the resultant force F2 minus F1 or F1 minus F2, whether it will act towards O or not, that is not guaranteed. It is guaranteed if we have moved along the towards the midpoint of DC. But if you displace it slightly in other direction, that F2 minus F1 or F1 minus F2 not going to be directed towards O. If it is not going to be directed towards O, then stable equilibrium is not established. Okay, I hope you have understood how to solve problems of electrostatics based on Coulomb's law. Now you try it from your textbooks. Yeah.